Welcome to this particular video, and in here we're going to look at solving speed and velocity part 1, where we're going to look at the following in terms of the strategy. First is we need to be able to find three things. One is when you're asked to determine what the average speed is, what do you need to have in order for you to accomplish this? One here is you need the distance and you need the time, and those are the two things to remember when it comes to determining what the average speed of an object is. And next is, what if you're asked to determine what the velocity of an object is? What are the things that you need to remember? You need one, the position of that particular object, and next is to determine or find the time. And once you have these two variables, you'll be able to determine what the velocity of that object is. And finally, here is when you're asked to determine what the relative velocity of an object is, what do you need in order for you to accomplish this? There are two parts here. One is when you have velocities to be equal to 90 degrees, and while the other part is where the one vector and the other vector doesn't have angles that is equal to 90 degrees. And so we're going to look at three of these particular scenarios when it comes to questions. We're going to look at average speed, we're going to look at velocity, and we're going to look at where the relative velocity is going to be the combination of one vector that is equal to 90 degrees in terms of the direction and the other as well. And we're going to look at case number 1. And for case number 1, we need to look at the following. When you're given a question that says that an object, in this case, let's say a ball here, is traveling at a particular distance to be 160 kilometers, and it says that the time it takes is, in this case, equal to 2.0 hours. The question says that we should find the average speed, and this is a symbol for average speed, the V average. And now for we to determine this, we need to ask ourselves the question, what are the specific formulas that are needed in order for we to accomplish this? The formula in this case that you need is the S is equal to V average multiplied by your time. And once you have this, we can then rearrange and solve for our V average. And to do that, all we have to do is you divide your distance by your time. And once you have this, we can then move on to our solution or solving for our V average. And take note that the speed is a scalar quantity, and this here is going to be equal to our distance, which is 160 kilometers. This is divided by your time to be 2.0 hours, and this here, once you divide it, you're going to get your answer to be 80 kilometers per hour. So this is one case scenario where we have the distance to be given, and we have our time to be given, and we are asked to find what the average speed is. And this is the thing to keep in mind. Take note that to know that this is average speed, there is no vector symbol that is above your variable. And so if there is a vector symbol here, then we need to recognize that that is not average speed. But the other case scenario, which is case number 2, is where you're given various variables, like for example a plane is flying. Sorry for my drawing of a plane, not the best drawing in the world. And this is case number 2, and in here we are asked that this plane travels at a particular displacement, or we just say position of this plane is 600 kilometers due north, and in this case it means that the arrow is going to be pointing up in that direction. And take note that we need also other things to be aware of. We need our coordinates, where this is our north, and we can have this to be our east, this is going to be our south, and this here is going to be our west. So in this part here, we have this to be our position, which you're going to have this to be a vector with the arrow above your variable, and this is, remember, we are given also the time to be equal to 3 hours and 15 minutes. And so this can be transformed to decimal, which is equal to 3.25 hours, and that is going to be important as we solve for the unknown variable, which is in this case our velocity, which we're asked to find. And through analysis, we are now going to be able to recognize that yes, since we're asked to determine what the velocity is, the velocity formula is equal to our position divided by your time. And since we have these, we know that we are already going to solve, or it's already shown that we are solving for v average or vector average. Therefore, substitute our numbers for the variables, and we have our v average vector to be equal to 600 kilometers north divided by your time, 3.25 hours. And therefore, this is going to give us our velocity to be equal to 185 kilometers. Remember that because this is a vector, we not only need our magnitude, which is 185 kilometers per hour, but also we need our direction to be, in this case, north. And so this here is our final answer for our velocity. So remember, while our speed doesn't show you the direction, our velocity tells us the direction that our object is positioned at. So that is the case number 2. And the final case here, which we're going to look at, is when we are asked to address the elephant in the room, which is how about we are going to be determining the relative velocity. And so this comes handy when an object is moving relative to a specific frame of reference. And an example here is when you're given a specific drone. I don't know, this is not the best drawing for a drone, but you know what, just going to simplify the drawing. And this drone flies at a particular speed that is equal to 265 kilometers per hour due north. And in this case here, we have this to be the vector that is showing the direction of this particular object relative to without air, and this velocity of this object we're just going to represent as vector VP, and this is going to be experiencing a wind velocity that is east, and this here is going to represent as the vector V with W, and this wind velocity is equal to 55 kilometers per hour east. And our question here is to determine what the resulting velocity is, and this here is where you need to be able to recognize that the combination of the wind velocity and the drone's velocity without wind will give us the resulting vector to be the combination of these two vectors, and therefore you're going to start with the tail end and head to the head end. And so we are going to connect this, and this is the direction of our resulting velocity. And therefore, once we have this, we not only need to determine what the magnitude of this is, but also we need to determine what the direction is. We need to now be able to introduce another thing in order for we to establish the specific direction, which is introducing your cardinal point. And so take note that north here, this is east, and then this is south, and this is our west. So once you're able to accomplish this, first is we need to determine what the direction is, which is what is our angle. And so to determine what the angle is, we need to remember that the angle, which is theta, this side that is facing the angle is known to be called the opposite, and by default this is called the adjacent. So our opposite is going to be this, and therefore tan theta is going to be equal to VP divided by our VW, and therefore this here is going to tell us that 265 kilometers per hour divided by 55 kilometers per hour will give us, and your theta, which is your inverse of tan, is going to be equal to, remember that this angle here is just pointing from west to north, and so if you want to give another direction, this can be expressed also as 180 degrees minus 78.3 degrees, and this will be equal to, and this here is looking at the particular direction here, which is unit circle, and so this here is 101.7 degrees. And finally is what if we're asked to place it based on the north direction, and so from north to wherever the arm is, what is alpha? And to determine what alpha is, we're going to have 90 degrees minus 78.3 degrees, and this alpha here is going to be north 11.7 degrees west. So that is our direction, and the other part here is to determine what the magnitude of your VR is, and the magnitude of our VR is going to be equal to the square root of the sum of the squares of your VP and that of your VW. And therefore, once we have this, and we take note that this here square is going to be taken out, and we put in our values, we are going to have the square root to be, and therefore our resultant velocity is going to be equal to 271 kilometers per hour, and while the direction of our relative velocity is equal to north 11.7 degrees west. I hope you found this really informative in terms of the three case scenarios. The second one, which involves looking at how to determine the velocity. The first case involves how to determine the speed given the following variables, and finally the third case scenario, which involves relative velocity with respect to when each of the components has angles that is either 90 degrees or 180 degrees. All the same, thanks for following us through this. Truly appreciate it. Hit a comment down below. Let me hear your thoughts about this. So speed and velocity part 1, and our part 2 video will look at more things to come. All the same, stay smart as always and believe in yourselves.